Do you know how gold is mined? The gold mining process begins with surveying and excavating areas with gold reserves. The excavated soil and rocks are transported to an initial processing area. Here, high-pressure water jets are used to remove the lighter soil, separating the gold-containing ore. This mixture is then passed through a vibrating screen system to filter out the finer soil, which often contains tiny gold particles. Next, the fine ore is fed into a grinding machine to be finely ground into powder, releasing the gold from the surrounding rock layers. This powder is then treated with chemicals such as cyanide or mercury to dissolve the gold and separate it from other minerals. After the gold is recovered in the form of crystals or powder, it is washed, dried, and then melted in a furnace at temperatures above 1000 degrees Celsius. The molten gold is then poured into molds to form shiny gold bars that can be used in industry, jewelry making, or stored as valuable assets. In today's video, I will take you to a gold mine in the Arctic at -71 degrees Celsius, from mining to the gold smelting plant. The first thing you see is white, not a town, not a road, just an endless sheet of Arctic snow, torn only by a narrow strip of gravel runway. Our small plane drops through a curtain of frozen mist, and the pilot's voice crackles in my headphones. Welcome to Kupol. Out here in Chukotka, in the far northeast of Russia, there is no highway, no village nearby. Only a mine that looks like a lunar base, carved into permafrost at the end of the world.
I'm here as a field reporter, not in a city newsroom, but in one of the most isolated gold-silver mines on Earth.
This single mine, together with its satellite deposit Dvoynoye, has delivered millions of ounces of gold and tens of...
We are now at the edge of the open pit, a truly immense human endeavor carved into the frozen earth. Deafening. This is where the complex alchemy of extraction truly begins, breaking down the rock. Every stage is carefully controlled, from the desolation of the Arctic to the heart of this industrial marvel, Kupol is a global supplier.
Up there is waste rock, and down there is ore. Every blast, every single ton of ore, it's meticulously tracked from here. From these rock faces, thousands of tons will move towards the crusher within 24 hours. This feeds our mill, which processes around 3,000 tons every single day. And that capacity grows even further when we blend in additional ore from Dvoynoye. We coordinate real-time movements across all levels here. This entire cycle, from blast to mill, is a continuous 24-hour operation. Now we head underground, into the heart of the operation. This is where 60% of our gold truly begins its journey. These are our drill rigs, the true muscle underground. Operators are safe in cabins, sometimes even remotely controlling them. These remote-controlled rigs are the muscle, hammering out patterns for the next blast. Operators manage these rigs from protected control cabins, minimizing exposure to rock falls. Each hole is precisely placed, part of a calculated design to loosen the ore efficiently. 60% of Kupol's gold originates right here, deep within this underground maze. The floor vibrates constantly, a reminder of the powerful work happening all around us. Millions of impacts, every thud of the drill, every load of blasted rock contributes to our goal. After the blast, the ore is loaded into trucks and begins its journey out of the mine. It's a complex dance of machinery and logistics, all happening hundreds of meters beneath the surface. Hundreds of thousands of ounces of precious metal are produced through this meticulous underground work.
From here, the rock travels to the surface for further processing, inching closer to becoming pure gold.
After the blast, it's all about moving the broken ore efficiently. These loaders work tirelessly to get the ore out of the tunnel and to the surface processing.
Every truckload represents a step closer to extracting the valuable gold. Once the ore reaches the surface, the journey of separation truly begins.
Here, we prepare the ore for crushing, removing larger rocks that aren't valuable. Grinding is essential. It liberates the tiny gold particles trapped within the rock.
These sluice boxes use gravity to separate the heavier gold from the lighter sand and mud. After multiple stages of concentration, we finally have pure gold concentrate, ready for smelting.
The high temperatures melt the gold, burning away impurities and allowing it to be cast.
And this, finally, is the end product of countless hours, intricate engineering, and immense dedication.
Producing this much metal in such a remote place demands a second, invisible operation: logistics. Between January and April, Kupol is connected to the outside world by a 360-kilometer winter ice road from the port of Pevek. Fuel, reagents, spare parts, even food for the canteen are ordered up to 2 years in advance and hauled in thousands of truck trips before the road literally melts away. I ride along in one of the supply trucks as it unloads fuel at the tank farm. The driver laughs when I ask what happens if something critical is forgotten. Then we improvise, he says, or we wait a year. But that spreadsheet will never show the frozen breath of the drillers at the face, the long months away from family, the risk calculated into every blast pattern, or the silent beauty of green auroras hanging over a steaming gold plant at 50 degrees Celsius. That is why places like Kupol need witnesses, not just investors, but storytellers. Today, that witness is me. Tomorrow, it might be you, watching this report and realizing that behind every gram of gold lies a landscape, a community, and a story carved into the ice. From here, the process leads us into the workspace where the gold is kept and gradually crafted into bars. The path narrows as the main corridor bends toward a heavily controlled section of the facility. Ahead, the first thing that stands out is the gate. Not ornate or theatrical, but precise. A waist-high barrier of brushed stainless steel is integrated seamlessly into a glass wall that spans from floor to ceiling. On the other side of that glass, security staff sit behind a console that looks more like an air traffic control station than a reception desk. Multiple screens, live camera feeds, scrolling data from access logs. The approach zone is marked clearly on the floor. Yellow lines define where people can stand. Red rectangles indicate where cargo trolleys must pause. A ceiling-mounted camera tracks every motion with small, almost imperceptible adjustments. No raised voices, no tension, just quiet. Rehearsed procedure. Security personnel wear dark uniforms with minimal insignia, earpieces tucked behind the ear, tablets in hand. Each person entering presents a badge to a reader, embedded in a short pillar. The reader emits a soft chime as the system pulls up identity, clearance level, and current task. For staff, the process continues with biometrics. A glass panel brightens, and a faint outline shows where to place a hand. The scanner reads palm patterns and temperature, then pairs that biometric with the live camera image. A slim status bar at the top of the glass shifts from amber to green. If anything is out of step, a mismatch in schedule, a missing authorization code, the barrier simply does not react. There is no alarm, just an unbroken line of metal and glass refusing to move. Beside the personnel gate, a parallel lane is dedicated to material. Trolleys carrying sealed boxes of gold follow a track guided by optical sensors. At the checkpoint, the trolley passes through an archway studded with discrete modules, weight verification platforms in the floor, radiation detectors, and metal analyzers concealed in the frame. The system confirms that what is entering matches the manifest. Expected number of boxes, expected mass, expected identifiers. When everything aligns, a small indicator above the arch glows green, and the inner doors prepare to open. Beyond the gate lies the first door into the workspace proper, an airlock rather than a simple passage. The room is compact and bare, with smooth walls and no exposed wiring. The door behind must fully close and seal before anything ahead will operate. Pressure and airflow are controlled here. A soft rush of filtered air pushes dust outward, away from the secure interior. The airlock's inner door has no handle, just a vertical strip of matte black glass. Status lights are tucked into the frame, visible, but not demanding attention. When the control system is satisfied, the strip pulses once, and the door slides sideways on a hidden track, almost silent. Inside, the change in atmosphere is immediate. The floor is a continuous surface of light gray epoxy, slightly reflective but not glossy. Overhead, rows of LED panels emit a daylight-balanced glow that eliminates harsh shadows. The temperature is cool but constant, and the air is exceptionally clean. No drifting particles in the light, no smell of oil or dust. Machines are organized into lanes that run parallel across the room, with clear walkways between them. Every cable is routed through floor ducts or overhead trays. Every pipe is labeled and color-coded. On one side, an enclosed storage area houses the incoming gold in its interim form. Transparent panels allow supervisors to see inside without opening anything. Within, heavy shelves of powder-coated steel hold sealed containers, each box tagged with a small electronic label that updates itself via the internal network. A ceiling-mounted robot, running along a fixed rail, can move down the aisles to pick and place containers as needed. Its movements are slow and deliberate, the arm extending, clamping, and retracting with mechanical precision. No unnecessary motion, no wasted time. The heart of the workspace is the line where the gold is transformed from secured inventory into small, finished bars. The line begins at a loading station, where containers are docked to a feed module. Instead of people lifting bars by hand, a compact robotic arm, fitted with a gripper designed for high temperatures, takes over. It opens the container, removes pre-processed ingots, or semi-finished pieces, and places them onto a series of conveyors that feed directly toward the melting furnaces further down the hall. The furnaces themselves sit inside glass-fronted enclosures. Stainless steel frames hold thick panes that resist heat and impact. Through them, it is possible to see the controlled glow of the crucibles inside, but not feel the radiated heat. Each furnace is paired with an overhead exhaust hood that connects to a filtered ventilation system. Nothing leaves the chamber without being treated and measured. Status screens mounted beside each enclosure display temperatures, melt composition, and operating parameters in clean, simple graphics. When a batch is ready, a tilting mechanism inside the enclosure pours molten gold along a short, shielded channel into pre-arranged molds. This casting zone is another island of machinery, a row of graphite molds aligned on a moving table, sensors checking fill level and temperature, small cameras watching for imperfections. The entire cast area is enclosed by a low barrier with transparent screens, and the only moving presence within is a robot. Its articulated arm adjusts mold positions, swaps out trays, and handles minor adjustments without interrupting the flow. As the molten metal solidifies into bars, the table slides under a controlled cooling section. Here, air nozzles and cooling plates are operated by another set of automated regulators. The goal is consistency rather than speed. The bars pass through thermal zones that bring them from casting temperature down to a stable, manageable warmth. Data from each bar casting time, mold ID, cooling curve is logged as they move, linked to their eventual serial numbers. Beyond cooling, a second group of machines takes over for finishing. A compact robotic arm lifts each bar and passes it under a surface scanner. High-resolution cameras inspect the edges and faces, checking for pits, cracks, or distortions. If a defect is detected, The robot diverts the bar onto a separate lane that leads back to remelt. Acceptable bars travel straight ahead into the stamping unit. Here, guides center each bar beneath a press head, and the machine lowers a hardened die with a controlled, measured impact. The resulting imprint logo, weight, purity, number is immediately photographed and compared to digital templates for clarity and alignment. Throughout this area, doors to side rooms and control hubs share a similar design language. They are flush with the walls, finished in muted tones, with only a narrow vertical window or a small illuminated panel to distinguish them. Access is segmented: casting, finishing, storage, and control. Each have their own zones, each requiring appropriate credentials. If someone without the right level attempts to open a door, nothing dramatic happens. The panel simply remains dark, and the system records the attempt. On an elevated platform overlooking the production floor sits the control room. It is separated by thick glass, with a single secure door leading inside. Operators sit at consoles curved around a bank of displays. Live feeds from cameras, diagrams of the line, numerical readouts of temperatures and weights. Everything is present, but arranged to be read at a glance. The room is quiet, voices low, the only constant sound, the soft hum of electronics and the distant, muted rhythm of machinery through the glass. Below, the gold moves without hurry. Bars travel in single file along conveyors, pause under scanners, stop briefly at weighing stations where precision balances, check that each piece matches its specification. A second robot further down stacks finished bars into small groups on trays, aligning them neatly before an automated wrapper shrinks protective film around the set. These wrapped sets are then placed into transport boxes by yet another mechanical arm, each box tagged immediately with a code that ties it back through every step that came before. At the far end of the workspace, another modern door waits this one, with a thicker frame and a more prominent access pedestal. Beyond it lies the deeper storage, the vault area. The production floor stops here. No machine crosses this threshold. Instead, the boxes are handed over, one by one, from automation to human custody. The transition is smooth, almost invisible, but significant. Inside the workspace, robots and systems dominate. Past the door, the emphasis shifts fully to security and accounting, where each box of bars becomes part of a ledger that reaches well beyond the walls of the building.